I was fortunately exposed to Vladimir's thesis prior to these presentations, so I would just share my experience uh, as to how to listen to this series of presentations by giving my reaction and my evolutionary thinking. When I went to college, my primary assumption was that all the physics professors were the best minds in the world, and all of their ideas had been proven to 9 decimal points. So I was just there to look to learn. And then I found some things puzzling about special relativity and delved into it, and eventually came to the conclusion that special relativity was only inadequate, but really a step backwards. Now, one might think that would give me maybe a skeptical attitude about the rest of physics, but when I was in the CNPS, presented with ideas about quantum mechanics, thermodynamics, cosmology, I would tend to dismiss them as not being consistent with what I've been taught, and that was a mistake. So similarly, when Vladimir presented some of his ideas, and I was reading, I came across dark matter, and I thought, oh yes, someone in CNPS has shown that dark matter is an unnecessary concept. So the best way to approach, particularly something of this scope, a change of paradigm, is not to look at things point by point and sort of say, oh, dismiss the whole thesis because it's not in accord with your particular current idea of what's true and what's not true. Certainly, so going through all 8 presentations, I think there is a tremendous amount of new ideas that have a deal of validity behind them. So yeah, by all means, ask questions about for clarification, or even if you think that a particular point is wrong, you can present your idea, but just keep an open mind until you have received the total gestalt presentation, because I think the whole is greater than the sum of its parts. So that's probably decent advice for any brand new ideas that are being presented. Just keep an open mind and be receptive to the whole idea. I think it's a wonderful series of presentations.
Well, so good day to you, good morning to you, and good afternoon from here, Vladimir.
Hello, everyone. Thank you for coming. Let's start. Thank you so much. I will read the text of my presentation with some comments. Hope that this helps you to better understand the essence of my model. Nick recommended me to do this. First of all, let me introduce myself. I received a Master of Science degree from Moscow Institute of Physics and Technology, a PhD in quantum electronics from Moscow Lebedev Physical Institute, and a Doctor of Sciences in laser physics from Moscow Institute of General Physics. I have published over 200 papers, including 40 articles co-authored by Alexander Prokhorov, Nobel laureate in physics 1964. Since 2001, I have been developing a model that I dubbed World-Universe Model, WUM, which is in fact a paradigm shift for cosmology and classical physics. WUM has had a good record of accomplishment on predicting cosmological parameters with a high degree of accuracy. In 2014, Liu, who was one of the organizers of the Kodata Royal Society meeting in London, said, "The Newtonian gravitational constant G holds an important place in physics. Though there have been about 300 measurements of G since the first laboratory measurement by Cavendish over 200 years ago, its measurement precision is the worst among all the fundamental physics constants. In 2013, based on the revealed interconnectivity of cosmological parameters, Wong calculated a value of G and recommended it to all members of the meeting. No breakthrough in G that measurements have been achieved in 2014. Nevertheless, in 2015, Kodata recommended a value of G that is 3 times more accurate than the previous one. In 2018, the recommendation improved further. Since 2013, the relative standard uncertainty of G measurements reduced 6 times. It was the very first success of WOM. Over 200 years, about 300 measurements, and no success. The very first proposal of WOM and the accuracy of the measurement increased 3 times. Not bad for the beginning. Physics and mathematics. Physics is an experimental science. In my opinion, there is a principal difference between physics and mathematics. I am convinced that physics cannot exist without mathematics, but mathematics must not replace physics. It is exactly what has happened for the last 100 years. I absolutely agree with John von Neumann, who said, the sciences do not try to explain, they hardly even try to interpret. They mainly make models. By a model is meant a mathematical construct which, with addition of certain verbal interpretations, described observed phenomena. The justification of such a mathematical construct is solely and precisely that it is expected to work. In my view, the value of models is not only describing observed phenomena, but making verifiable predictions and setting up targeted experiments based on the obtained experimental results. Classical physics. Emergent phenomenon. By definition, emergent phenomenon is the property that is the result of simple interactions that work cooperatively to create a more complex interaction. They occur at a microscopic level, and the collective result can be observed at a macroscopic level. For example, temperature of the ideal gas, that is a classical notion, is proportional to the average kinetic energy of its particles. The temperature knows nothing about movement of each particle, and particles have kinetic energies only. They have no idea about the temperature. Classical physics is dealing with ensembles of quantum objects. Electrodynamic constant. In 1857, Weber and Kohlrausch determined that there was a quantity related to electricity and magnetism, the ratio of the absolute electrostatic unit of charge to the absolute electromagnetic unit of charge, and determined that it should have units of velocity. In modern language, it is an electrodynamic constant C according to formula where mu0 is the permeability of free space and epsilon 0 is the permittivity of free space. They measured this ratio by an experiment which involved charging and discharging the Leyden jar and measuring the magnetic force from the discharge current, and found the value of C remarkably close to the speed of light, which had recently been measured by Fizeau in 1849. However, Weber and Kohlrausch didn't make the connection to the speed of light. They were genius. To measure one of the most important electrodynamic constants by experiments with Leyden jar, it's unbelievable. Maxwell equations were published by Maxwell in 1861. He calculated the velocity of electromagnetic waves from the value of the electrodynamic constant C measured by Weber and Kohlrausch, and noticed that the calculated velocity was very close to the speed of light measured by Fizeau. This observation made him suggest that light is an electromagnetic phenomenon. We emphasize that C in Maxwell equations is the electrodynamic constant, but not the speed of light in vacuum. According to Maxwell equations, electromagnetic waves in any bulk material travel at velocity that is a function of permeability and permittivity of material, where mu m is equals mu r mu 0, epsilon m equals epsilon r epsilon 0, and mu r and epsilon r are the relative permeability and permittivity of the material respectively. Then the velocity of electromagnetic waves equals to c over root square of mu r epsilon r. In case of vacuum, mu r and epsilon r equals 1, the velocity equals c. In case of outer space, with mu r more than 1, the velocity less than c. It follows that there is no miracle in the maximum value of the velocity of electromagnetic waves that equals to the value of the electrodynamic constant c. In any bulk material, the velocity less than c. Ether. Physical ether was suggested as early as 18th century by Newton. Following the work of Young and Fresnel, it was believed that light propagates as a transverse wave within an elastic medium called luminiferous ether. At that time, it was realized that ether could not be an elastic matter of ordinary type that can only transmit longitudinal waves. Unique properties of ether were discussed by Mark Kulak in 1846, who proposed a theory of rotationally elastic medium. The potential energy of deformation in such a medium depends only on the rotation of the volume elements and not on their compression or general distortion. This theory produces equations analogous to Maxwell equations. Ether with these properties can transmit transverse waves. He was a genius. It turned out that abandoning of the luminiferous ether in 1905 by special relativity was crucial for classical physics. It is a great pity that the mainstream physicists at that time did know or forgot a theory developed by Mark Kulak, who said, "The constitution of the ether, if it ever would be discovered, will be found to be quite different from anything that we are in the habit of conceiving, though at the same time very simple and very beautiful. An elastic medium composed of points acting on each other in the way supposed by Poisson and others will not answer." The Friedmann equations were derived in 1922 from Einstein's field equations for Friedmann, Lemercier, Robertson, Walker method, and a perfect fluid. Ether exists or not in general relativity. In later years, there have been classical physicists who advocated for the existence of ether. Nikola Tesla declared in 1937, "All attempts to explain the working of the universe without recognizing the existence of the ether and the indispensable function it plays in the phenomena are futile and destined to oblivion." Paul Dirac stated in 1951 in an article, "Is there an ether? That we are rather forced to have an ether." WOM is based on Maxwell equations. Mark Kulak theory is a good fit for description of the medium. There are no luminiferous ether and vacuum. The model introduces the medium that is composed of stable elementary particles, protons, electrons, photons, neutrinos, and dark matter particles. Medium is a savior of classical physics. Don't throw the baby out with the bathwater. Hypersphere World-Universe Model. I would like to give you an introduction to my model so that you will be aware of a new picture of the world without details, which I will provide you in the following presentations. Primary assumptions. WOM is based on the following primary assumptions. World is a finite, boundless 3D hypersphere or 4D nucleus of the world, which is expanding along the fourth spatial dimension of the nucleus with speed equal to the gravity dynamic along constant c. The 3D world is curved in the fourth spatial dimension. Eternal universe is the creator of dark matter, which is continuously created in the nucleus of the world. Ordinary matter is a byproduct of dark matter particles self-annihilation. Medium of the world is an active agent in all physical phenomena in the world. Two fundamental parameters in various rational exponents define all macro and micro features of the world. Dimensionless Rydberg constant alpha, where R is the Rydberg constant and A is a basic size unit, and dimensionless time-varying quantity Q, that is in fact the Dirac's large number. Alpha now named the fine structure constant. Principal points. WOM is based on the following principal points. Beginning. The world was started by a fluctuation in the eternal universe, and the nucleus of the world, which is the 4D ball, was born. An extrapolated nucleus radius at the beginning was equal to the basic size unit of A. The extrapolated energy density of the world at the beginning, Qx1, was 4 orders of magnitude smaller than the nuclear energy density. The world is a finite, boundless 3D hypersphere that is the surface of the 4D nucleus. All points of the hypersphere are equivalent. There are no preferred centers or boundaries of the world. Stretching of the world. The 4D nucleus expanding along its fourth spatial dimension so that the radius of the nucleus R is increasing with the speed c, that is the gravity dynamic constant. Its surface, the 3D hypersphere, is evenly stretched. The stretching of the hypersphere world can be understood through the analogy with expanding 3D balloon. Imagine an ant residing on a seemingly two-dimensional surface of a balloon. As the balloon is blown up, its radius increases and its surface grows. The distance between any 2 points on the surface increases. The ant sees her world expand, but doesn't observe a preferred center. Unbeknown to ants, the center is not located on the surface, but instead is removed along the inaccessible third dimension. It is in the center of the balloon. What does the balloon expand into? It expands in perpendicular down-up direction that is inaccessible to perception, and therefore from the surface of the balloon. One cannot point out the direction of the expansion. Likewise, the 3D hypersphere world expands along the imperceptible fourth dimension. The center of the world is in the center of 4D nucleus, in that very inaccessible fourth dimension. We do not know that our 3D space is curved, but we know that it is stretching without center of stretching. According to WOM, all parameters of world depending on Q, which is the ratio of a radius to A, are a manifestation of the world's curvature in the fourth spatial dimension. Creation of matter. The surface of nucleus is created in a process analogous to sublimation. Continuous creation of matter is the result of this process. Sublimation is a well-known process that happens when surfaces are intrinsically more energetically favorable than the bulk of a material, and hence there is a driving force for surfaces to be created. The universe is responsible for the creation of dark matter in 4D nucleus of the world. Dark matter particles carry new dark matter into the world. Ordinary matter is a byproduct of dark matter particles self-annihilation. By analogy with 3D ball, which has a 2D spherical surface that has surface energy, we can imagine the 3D hypersphere world has a surface energy of 4D nucleus. The growth of the surface of 4D nucleus means that the increase of the world's so-named surface energy. Proposed 4D process is responsible for 4D nucleus expansion, 3D world stretching, creation of of matter, and arrow of time. It constitutes the main hypothesis of Wundt. In my view, the arrow of the cosmological time doesn't depend on any physical phenomenon in the medium of the world. It is the result of the nucleus expansion due to the driving force for surfaces to be created. It is important to emphasize that creation of matter is a direct consequence of the nucleus expansion. Creation of dark matter occurs homogeneously in all points of the hypersphere world. Content of the world. The world consists of the medium and macro objects. Total energy density of the world equals to the critical energy density throughout the world's evolution. The energy density of the medium is 2/3 of the total energy density, and macro objects, superclusters, galaxies, extrasolar systems, etc., 1/3 in all cosmological times. The relative energy density of dark matter particles is about 92.8%, and ordinary particles, protons, electrons, photons, and neutrinos, about 4.8% in the medium of the world and 2.4% in macro objects. Rotational fission. The mechanism that can provide angular momentum to macro objects is a rotational fission of overspinning, surface speed at equator exceeding escape velocity, prime objects. From the point of view of fission model, the prime object is transferring some of its rotational momentum of the prime object momentum to orbital and rotational momenta of satellites. It follows that the rotational momentum of the prime object should exceed the orbital momentum of its satellite. In Wundt, prime objects are dark matter cores of superclusters, which must accumulate tremendous rotational angular momenta before the birth of a luminous world. It means that it must be some long enough time in the history of the world, which we named dark epoch. Dark epoch is spanning from the beginning of the world, 14.22 billion years ago, for 0.45 billion years for Laniakea supercluster that is home to Milky Way galaxy, when only dark matter macro object existed. Luminous epoch is lasting ever since for 13.77 billion years, when luminous macro objects emerged due to explosive volcanic rotational fission of overspinning dark matter superclusters cores and self-annihilation of dark matter particles. Macro object shell model. Macro objects of the world possess the following properties. Their cores are made up of dark matter particles. They contain other particles, including dark matter particles and ordinary particles, in shells surrounding the cores. Introduce weak interaction between dark matter particles and ordinary particles provides integrity of all shells. Dark matter reactors. Macro object cores are essentially dark matter reactors fueled by dark matter particles. All chemical elements, compositions, radiations are produced by macro objects themselves as the result of dark matter particles' self-annihilation in their dark matter cores. Nucleosynthesis of all elements occurs inside of macro objects during their evolution. Macro object formation. Superclusters are the principal objects of the world. Macro objects, superclusters, galaxies, and extrasolar systems form in parallel around different cores made up of different dark matter particles. 3D finite boundless world presents a patchwork quilt of different luminous superclusters which emerged in different places of the world at different cosmological times. The distribution of macro objects in the world is spatially inhomogeneous and anisotropic and temporally not simultaneous. Macrostructures of the world form from the top superclusters down to galaxies, extrasolar systems, planets, and moons. Macro objects evolution. Formation of galaxies and stars is not a process that concluded ages ago. Instead, it is ongoing. Assuming the eternal universe, numbers of cosmological structures on all levels will increase. New superclusters will form, existing clusters will obtain new galaxies, new stars will be born inside existing galaxies, sizes of individual stars will increase. Most direct observational evidence of validity of WOM. Microwave background radiation, MBR, intergalactic plasma, and far-infrared background radiation speak in favor of existence of the medium of the world. Laniakea supercluster with binding mass about 10 to the power 17 mass of the Sun is home to the Milky Way galaxy and about 10 to the power 5 other nearby galaxies, which did not start their movement from initial singularity. The neighboring superclusters are Shapley, Coma, and Perseus Pisces. Distance from the Earth to the center of the Laniakea superclusters is about 250 million light years. Milky Way is gravitationally bounded with the Virgo supercluster and has an orbital angular momentum calculated based on distance of 65 million light years from the Virgo supercluster and the orbital speed of about 400 kilometers per second, which far exceeds rotational angular momentum of Milky Way. Mass-to-light ratio of the Virgo superclusters is about 300 times larger than that of solar ratio. Similar ratios are obtained for other superclusters. These ratios are main arguments in favor of presence of significant amounts of dark matter in the world. Astronomers discovered the most distant galaxy, HD1, that is 13.5 billion light years away, and a candidate galaxy F200DB-045, which is 13.7 billion light away. As a conclusion, medium of the world, dark matter, and angular momentum are main three pillars of WOM. The described picture of the world is in fact a paradigm shift for cosmology. Medium of the world. WOM introduces the medium of the world, which consists of stable elementary particles with lifetimes longer than the age of the world: protons, electrons, photons, neutrinos, and dark matter particles. The medium is homogeneous and isotropic. The existence of the medium is a principal point of WOM. There are no luminiferous ether, perfect fluid, and vacuum in WOM. Intergalactic voids discussed by astronomers are in fact examples of the medium and its purest. MBR is a part of the medium. It then follows that the medium is the absolute frame of reference. Relative to MBR rest frame, the Milky Way galaxy and the Sun are moving with the speed of 552 and 370 kilometers per second, respectively. Time, space, and gravitation are closely connected with impedance, gravitomagnetic parameter, and energy density of the medium, respectively. It follows that neither time, space, nor gravitation could be discussed in absence of the medium. WOM confirms the supremacy of matter postulated by Einstein. When forced to summarize the theory of relativity in one sentence, time and space and gravitation have no separate existence from matter. There is no medium, there is nothing. Womb based on cosmological time tau that marches on at the constant pace from the beginning of the world up to the present epoch, along with time-varying cosmological parameters. Gravity is not an interaction, but a manifestation of the medium. Principal role of Maxwell equations. Maxwell equations form the foundation of classical electrodynamics and gravitomagnetism. The value of Maxwell's equations is even greater because Swain showed that linearized general relativity admits a formulation in terms of gravitoelectric and gravitomagnetic fields that closely parallels the description of the electromagnetic field by Maxwell's equations. We emphasize that gravitomagnetism considers not only interactions between masses, but also between mass currents. Ludwig, in a paper, Galactic Rotation Curve and Dark Matter According to Gravitomagnetism, published in 2021, wrote, most theories used to explain the rotation curve have been restricted to the Newtonian potential framework, disregarding the general relativistic corrections associated with the mass currents. The effects attributed to dark matter can be simply explained by the gravitomagnetic field produced by the mass currents. The explanation of galactic rotation curves made by Ludwig is in a good agreement with whom? Directly measured cosmological parameters. There are only two directly measured cosmological parameters, the gravitational parameter G and the temperature of cosmic microwave background radiation. Lee et al. Experimentally measured the most accurate value of G using two independent methods with accuracy about 11.6 parts per million, which are in excellent agreement with the value of G predicted by Wum in 2013. Please compare the value of G1 with the calculated value by Wum. In 2009, Dixon measured the value of ambient temperature with accuracy 30 parts per million. It means that the most accurate parameter of G is G, and all other cosmological parameters could be in principle calculated based on the value of G with the same accuracy. Thanks to revealed by Wum interconnectivity of cosmological parameters, we show that G that can be measured directly makes measurable all cosmological parameters which cannot be measured directly. We will discuss it beneath. Interconnectivity of cosmological parameters. Below, I am not going to overload you with mathematics. My intention is to prove that all cosmological parameters are calculated with well-known classical equations. The constancy of universe fundamental constants, including G, is now commonly accepted, although has never been firmly established as a fact. A commonly held opinion states that gravity has no established relation to other fundamental forces, so it doesn't appear possible to calculate it from other constants that can be measured more accurately, as is done in other areas of physics. Wum holds that there indeed exist relations between all cosmological parameters that depend on dimensional time-varying quantity Q. We will discuss it below. That is a measure of the size R and H tau of the world according to the equation, where T0 is the basic unit of time, Q in the present epoch equals to this value. Energy density of the world. Imagine that the world is a Hubble bubble with the radius r equals c tau, where c is the gravitodynamic constant and tau is a cosmological time, and n an energy density of a spherical surface that equals to a basic unit of surface energy density, sigma 0, that equals hc over a cube, where h is the Planck constant. With Nikola Tesla's principle at heart, there is no energy in matter other than received from the environment. We calculate an energy of the world and its average energy density that is inversely proportional to R. Rho 0 is the basic unit of energy density. Critical energy density. The principal idea of Wum is that the energy density of the world equals to the critical energy density, which can be found by considering a sphere of radius Rm and an enclosed mass m that can be calculated by multiplication of critical mass density by the volume of the sphere. When the world has the critical energy density, a Hubble velocity equals to the escape velocity, which gives an equation for the critical energy density. We emphasize that rho critical can be found by the Hubble's law only. We do not need general relativity for this. This equation can be written as follows, where μg is the gravitomagnetic parameter and rho m, 2/3 of rho critical, is the energy density of the medium. Considering that h inversely proportional to r, it is easy to see that the gravitational parameter g is inversely proportional to r too. We emphasize that the values of the main cosmological parameters g and h depend on the value of the energy density rho m, that is the characteristic of the medium of the world, which is the homogeneous and isotropic. Gravitational parameter g and Dirac large number q. Considering equations which we discussed before, we can find the following equation for g. An average value of gravitational parameter g average of experimentally measured values by Lee et al. Allows us to calculate value of q average based on value of g average. Below, we will use the value of q average for the calculation of all cosmological parameters. Intergalactic plasma. In whom the world consists of stable elementary particles. Protons with mass mp and electrons with mass me have identical concentrations. According to plasma physics, intergalactic plasma consisting of protons and electrons has plasma frequency according to the equation. We substitute the following equation into the equation above, where nu0 is a basic frequency unit, and calculate concentrations Np and Ne, which equals to 0.255 per cubic meter. Rho p is the energy density of protons in the medium. The relative energy density of protons in the medium is the ratio of rho p over rho critical, which equals to 4.8%. According to Wum, the relative energy density of baryons in macro objects is half of this value, 2.4%. In my opinion, measurements of intergalactic plasma parameters can be done by investigations of fast radio bursts, which are millisecond duration radio signals originating from distant galaxies. These signals are dispersed according to precise physical law, and this dispersion is a key observable quantity that, in tandem with redshift measurement, can be used for physical investigations. The dispersion measure and redshift conducted by Chiana et al. In 2016 provide the measurement of the cosmic density of ionized baryons in the intergalactic medium that equals to 4.9 plus minus 1.3%. That is in excellent agreement with the predicted by Wum in 2013 value 4.8%. Using the equation for electrons concentration, we calculated the value of photons time delay, which is in a good agreement with experimental and measured value by Keane et al. Please compare apple to apple. Minimum energy of photons. Analysis of intergalactic plasma shows that the value of the lowest plasma frequency, nu minimum, is about 4.5 Hz. Photons with energy smaller than H nu minimum cannot propagate in plasma. Thus, H nu minimum is the smallest amount of energy a photon may possess, which equals to the value about 1.8 multiplied 10 to the minus 14 electron volts. The above value predicted by Wong in 2013 is in a good agreement with the value obtained by Bonetti et al. In 2017. Origin of cosmic microwave background radiation, MBR. According to the standard Big Bang model, the photons that existed at the time of photon decoupling, 380,000 years after the Big Bang, have been propagating ever since, though growing fainter and less energetic since the expansion of space causes the wavelengths to increase over time. These photons are the same photons that we see in MBR now. But then, why is MBR a perfect black body? What is the mechanism of photons' wavelengths increasing over time and growing in fainter and less energetic? According to Wong, wavelengths is the classical notion. Photons, which are quantum objects, have only four momentum. They do not have wavelengths. By definition, black body radiation is the thermal electromagnetic radiation within or surrounding a body in the thermodynamic equilibrium with its environment. In Wong, the black body spectrum of MBR is due to thermodynamic equilibrium of photons with intergalactic plasma, the existence of which is experimentally proved by fast radio bursts. It explains why MBR is a perfect black body radiation. Rho E is the energy density of electrons in the medium. We assume that the energy density of MBR equals to twice the value of Rho E due to two polarizations of photons, and consider the Stefan-Boltzmann law, where Kb is the Boltzmann constant. The calculated value of TMBR is 2.725245 degrees Kelvin. Thus, calculated value is in excellent agreement with experimentally measured value of 272548 by Fixen in 2009. Let us proceed to calculate the value of TMBR at different ages of the world. At the age of 0.45 billion years, beginning of luminous epoch, the temperature was about 6.5 degrees Kelvin. At the age 9.6 billion years, birth of solar system, it was about 3 degrees Kelvin. At the age 14.22 billion years, present epoch, it's 2725 to 45 Kelvin, as I showed before. Observe that all macro objects, galaxies, stars, planets, moons, have arisen in the cold world. Our solar system, for instance, was created when the temperature of MBR was about 3K. Therefore, any model describing creation of macro objects must hold true in the cold world conditions. Far-infrared background radiation. The cosmic far-infrared background radiation, which was announced in 1998, is part of the cosmic infrared background with wavelengths near 100 micron, that is the peak power wavelengths of the black body radiation at temperature 29 K. We calculated the temperature of its peak, 28.955 Kelvin. That is in excellent agreement with the experimentally measured value of 29 K. Primary cosmological parameters. According to whom, the following parameters of the world depend on Q. Newtonian parameter of gravitation, Hubble's parameter, age of the world's radius of curvature, critical energy density, concentration of intergalactic plasma, minimum energy of photons, temperature of ambient, temperature of fine infrared background radiation peak. In frames of room, all these cosmological parameters are a manifestation of the world's curvature in the fourth spatial dimension. They can be calculated based on experimentally measured value of G average and Q average, as we showed above. Hubble's parameter and age of the world. The most important parameters in cosmology are the Hubble's parameter, H0, and age of the world, A tau, which we can calculate by the following equations. IH0 equals to 68.73 kilometers per second per megaparsec, and age equals to 14.22 billion years. We emphasize that the Hubble's parameter and absolute age of the world are determined by the experimentally measured value of G average. Hubble tension. The results of measurements of the Hubble's constant H0, which characterizes the expansion rate of the universe, shows that the values of H vary significantly depending on methodology. The disagreement in the values of H obtained by the various teams far exceeds the standard uncertainties provided with the values. This discrepancy is called the Hubble tension. In frames of room, the Hubble tension can be explained the following way. Hubble's law in standard cosmology is valid for the Big Bang model only, when all galaxies start their movement from a single point named initial singularity. That is not the case in room. The main conjecture of Big Bang model, projecting galaxies' trajectory backwards in time, means that they converge to the initial singularity at t equals 0, that is an infinite energy density state, is wrong, because all galaxies are gravitationally bound with their superclusters. In whom the 3D finite boundless world presents a patchwork quilt of different luminous superclusters, which emerged at different places and cosmological times. Please take a look at this figure. This is the picture of the real world. The redshift of the center of the Laniakea supercluster is 0.0708, but it does not mean that it is moving away from Milky Way. On the contrary, Milky Way is moving away from the center of the supercluster. Some galaxies are moving toward Milky Way, and the other are moving away. Then redshift depends on the position and movement of a particular galaxy in the supercluster against Milky Way. More complicated situation with redshift is when galaxies belong to neighboring superclusters. No wonder that, according to Gupta, over 8,300 belong to neighboring superclusters. Galaxies have been discovered beyond the local group in 2009. The Andromeda galaxy is the nearest galaxy to the Milky Way, which is blue shifted. How to explain all these results in standard cosmology? According to whom, the value of H should be measured based on MBR only. The calculated value of the Hubble's parameter in 2013 is in excellent agreement with the most recent measurement value in 2021 using only MBR data. Conclusion. Whom doesn't attempt to explain all available cosmological data, as that is an impossible feat for any one presentation. Nor does Whom pretend to have built an all-encompassing theory that can be accepted as is. The model needs significant further elaboration and should be developed into a well-elaborated theory by the entire physical community. WOM is a natural continuation of classical physics, and it can already serve as a basis for a new cosmology proposed by Paul Dirac. Considering GWST discoveries, successes of WOM, and 86 years of Dirac's proposals, it is high time to make a paradigm shift for cosmology and classical physics. Acknowledgements. I'm always grateful to academician Prokhorov and Professor Manenkov, whose influence on my scientific life has been decisive. I am eternally grateful to my scientific father, Paul Dirac, who was a genius and foresaw the future of physics in a new cosmology. I am forever grateful to Nikola Tesla, who was a genius. I am much obliged to Professor Korda for publishing my manuscripts in the Journal of High Energy Physics, Gravitation, and Cosmology. I am grateful to Nick Percival for his useful comments and suggestions, which have led to an overall improvement of the presentation. Special thanks to my son Ilya, who helped me clarify the model and improve its understanding. Thank you so much for your attention. I'm ready to answer all your questions. Please be ready.
Well, thank you very much for that very stimulating lecture. And that's only 1/8 of the totality of the subject that we'll be looking at, dealing with the world-universe model. The timing was perfect. You've actually got it to a T, Vladimir, in your rehearsal. And I think your exposition was actually very, very clear. Having the text up there, it was a little small for many of us, but if you maximized it, you could actually read what you were saying. Maybe just a couple of observations before going to the questions and discussion. But I was interested in a number of things. For example, you pointed to the initial measurement of the electromagnetic speed of light, if you like, from the electric and magnetic constants, the Weber-Kohlrausch experiment. And you said that was approximately, but not identically, equal to what we might term the kinematic speed, measured speed. So this is maybe giving us some idea that perhaps there's some medium there. If you could say something about how far your ideas would differ from those generally accepted.
Yes, sir. My theory principally different from general relativity. There is no connections between them at all. It is not continuation of general relativity. It is rejecting the general relativity as a theory of cosmology because it's not right for now. It's obsolete. We should accept it, that it is time to switch from one theory to another one. Let me repeat one more time. What does it mean in my view, the world? The world we live in. The world is only hypersphere of 4D nucleus. That's it. This is the world. What is important? It is finite, size finite, boundless, there is no bounds, and there is, expansion in the fourth spatial dimension. It is not expansion. We have a stretching of our world. That's why there is no expansion. Expansion in the fourth spatial dimension unacceptable for us. We don't know it, but we know that stretching, we can see all galaxies going out from each other, and we don't know why, because it's stretching. That's why it's totally wrong. Big Bang model, we don't know what is the size of the universe. 93 billion light years or even more, we don't know. In my case, we have the space measure radius of curvature. It's a real number. It's 10 to the power 26 meters. That's it, simple like this. It's a finite boundaries. In the universe, in my model, it's only creator of dark matter in the nucleus. There are no any parameters, characteristics of the universe. It's a creator. That's it. It creates dark matter continuously in our world, because we started with fluctuations without any matter, and we need all the time to put additional matter from universe. That's why I have to use universe, because universe something more great. Let me tell you such a word. In my view, it's a creator, like a god, for me and for my model.
Okay. Well, I'm not sure if you've dealt with this, because Cornelis says, "Oh, Vladimir, how is the accuracy of G verified in WEM?" But as far as I thought, you showed that the value of G coming out of WEM was very closely in agreement with the best experimental values.
Yes, man. You are absolutely right. But I calculated this value 5 years before. 5 years. I gave this number to London, to all the members of meeting. And I told, guys, take it. It's free, without money for you. They supposed even to do great experiments to confirm which group of the measurements correct. You know why was at that time the same problem as we had with Hubble tension? It was Newtonian gravitational parameter tension. 3 groups of the measurements totally different from each other, and nobody knew which one is correct. What is my point was at that point, guys, from these 3 measurement groups, take this one, and that's it. And it turned out now 6 times more accurate than it was for more than 200 years, and no additional experiments, nothing. There was only this Chinese experiment, which is to the power, to the 0.5 10 to the minus 5 accurate as my measure, the number. I was very impressed. Compare apple to apple, and you will see it is unbelievable how exactly number I proposed 5 years before them.
You see now, yeah, same question. So I think, again, you talked about a hypersphere, but question is asking, why is the hypersphere? You use that term.
Yes, because it's a well-known term. It's about, I don't know, Riemann here, oh my goodness, I cannot even calculate. 170 years ago, he introduced, by the way, that the world might be a hypersphere 170 years ago. That's why
it's beyond Euclidean. Yeah.
Yeah. And hypersphere means the sphere of the 4D ball. For our standard ball, we have simple sphere, and hypersphere means only increased dimension, 4th dimension, and hypersphere is a 3D hypersphere on a 4D balls. That's it. That's a definition.
Okay. So I mean, he's expressing it just in black and white here, but he says, do you accept the Big Bang theory? Well, I think you don't accept it as currently postulated, because you have some significant differences. But maybe to answer this question, do you accept that the universe has been in existence for a finite period of time, like 14.22 thousand million years, I think, came out of your value?
Yes. Our world exists, and the absolute age of the world, calculated based on gravitational parameter measured on Earth, 14.22 billion years. That's it. There was the beginning, but the beginning totally different. Instead of initial singularity with infinite energy density and all these mathematical tricks, inflation and all this stuff, there is none. There is a physical picture when you have some fluctuation with the real numbers, with size real, it's 10 to the minus 14 meters. energy density much less than our nuclear density, and then it is growing up as it should be in physics, not in mathematics, not with all these, tricks with mathematics, how to deal with infinities, infinite size of the world, of the universe, infinite density energy. I don't like it.
That certainly seems more satisfying, because to many of us, these sort of mathematical tricks have
Yes.
been just introduced to save existing conceptions. But thank you very much for expanding on that, because you, Nick, I know, as indeed Vladimir mentioned at the beginning, have been of use to him in formulating the papers in the first place and commenting. And I think Vladimir has always said he's made significant improvements based on your advice.
Yeah, that was a very limited improvement, nothing on his ideas, just how to present it to someone who knows nothing about the area.
That's what you want to do, because most of us here, have not looked into it in the same detail. So have you any response to Nick in regard to that? Thanks for that advice anyway.
Yes, I want to tell Nick, thank you so much for helping me how to present my results, because it is the most difficult part for me to have scientific publications and then to go to the lecture. That's why it was very important what you proposed, what you suggested. Even suggestions to read my text was very right, very right. That's why I will continue the same way all these parts. The main goal for this particular part one was the medium only. What I expect from you guys only to accept that medium does exist. There are confirmation of medium, at least 3 different parts, and its absolute frame of reference. Please take it as a law right now. The second point, what I try to show you, to give you, that in accordance with my model, I can calculate all these parameters, Hubble's parameter, temperature of microwave background radiation, this peak of cosmic far infrared background radiation, intergalactic plasma, and all these parameters that I calculated in 2013, and then I had a confirmation of them, always confirmation, and each confirmation was later, and it was very close to calculated by model. It's exactly advantage of my model that there was a prediction and then it was a confirmation. Even minimum energy of photons. Nobody believed, oh, photons, they have no mass at all. And I thought, no, guys, there is some minimum energy. Photons, they cannot have less. And then in 4 years, somebody measured and thought, yes, he's right. It's close enough to what I calculated before. That's why, please, don't overreact on the whole model, because it's very difficult to take it as it is. I wanted only to give you the brief ideas of the model, and then to talk about medium only. And then part by part, I will do my best to recover each point of this model. I gave it to you without details, and I will try to prove that it will give you full job when I will finish my part number 8 on 6th of July.
Yes, you're very early in the morning there. But I must confess that I had some very, very slight misgivings myself, in that one had to keep the audience, who are mainly technically conversant, but they're not specialists, engaged. And I felt that it might be too turgid having so many parts of it's a very comprehensive theory, and it does need all that. But actually today I can say that any of my misgivings have been completely vaporized, because you've presented something which is very, very interesting, I think. And I would appeal to people, I'll do this maybe in the summary as well, to await the further presentations, which I think will be all, just like that. They won't be very difficult to get through. Nick,
let me just add that, since Vladimir is a fire hose of information, don't get overwhelmed by, tons of empirical data and feel you have to memorize them or all these equations. Just be sure you're following it conceptually. The only point you have to remember is the empirical data is confirming these concepts. Thank you.
Important. Well, the time is creeping up on us, and we might just about have a few minutes for you to summarize, and maybe a few minutes for me to close the meeting and just tell people what we're going to expect next. So I'll give the floor to you to take a couple of minutes, or if you want to take 5 minutes, up to you, a minute or two, 5 minutes, just to summarize what you've done today, and maybe respond to any reactions, and maybe sort of confirm to people that a lot of these issues will be dealt with in subsequent presentations.
Okay. First of all, I would like to thank everybody who came to this meeting to listen to me and to take part in this meeting, answering some questions, listening to my answers, for interest in my work. Thank you so much, guys. It is very important. It is the very first my report, my lecture today, and it's a very important part of it to understand how to proceed, how to present my data, and how to deal with normal people with not high education in mathematics, but the ideas. My main comment is listen to my content, listen to my ideas, listen to what I'm talking about, follow my logic. If you have any questions with my logic, I will appreciate it, because it's very important for me to have your evaluation of my model. Then I can proceed with the next parts. Please have your patience, because it will be 8 parts, and the last one will be about classical physics. What should be done with classical physics? How we should update it due to the developed new model of cosmology, of new physics. Thank you so much for coming today. I hope to see you next time.
Well, thank you very much again, Vladimir. And it just devolves upon me to occupy the next couple of minutes and just officially closing the meeting. But I'd repeat what I intimated a moment ago, that I did have some reservations about going through so many parts on this model. And I thought it might sort of, frighten people if we told them too much about that. But actually, I'm quite satisfied now, having heard today, that this is going to be a very productive enterprise, and it's going to be quite exciting as well. And the only maybe negative thing is that a lot of the questions that are occurring to us now are perhaps best dealt with after the other parts have been considered, particularly next week, where we'll be looking at things like dark matter, and whether it's a good concept or not, or whether it's a different concept from the one which is normally displayed. But I'm convinced that we'll have a very significant series of lectures. There will be a break, as I say, after the next one, just reverting to some other topic, and then we'll continue again. And I think actually, looking at it globally, we shall have had the opportunity of really being exposed to a significant series of lectures, which really one could go to one of the universities and pay a hefty sum, I dare say, to have some professor lecture you on some of those ideas. And we'll have the opportunity of going through those and having, Vladimir himself presenting his ideas and answering any specific questions on that. And I'm quite convinced now that we made the right decision in devoting the coming months, actually, because these are only held every 2 weeks, these technical sessions. Yeah, that's right. We could watch again. So over the coming months, we'll have the opportunity of going through this. And it's a bit like, I think Nick said it was a gestalt, it's a German concept where in philosophy, where the whole is more than the sum of its parts. And I think Vladimir will be demonstrating very much that in the future.